Hey guys, coming at you live from Babytown. I'm a little sleep deprived, so hopefully we get through these problems okay. So, if you guys have looked on the website, the answer keys for the Barrett sniper rifle worksheet is up, and also the javelin throw is up. Now, I kind of screwed up on the sniper rifle worksheet, and by kind of, I mean totally, and didn't give you a height for the first problem. And since you didn't have the height for the first problem, you couldn't solve every problem after that. So, if you look at the answer key online on our website, it's got those problems worked out if I had given you a height and if I had slept recently. So let's work out some problems that are going to really help you on your quiz tomorrow. So let's say we've got a projectile launcher, and let's say we start off and we fire it 2 meters off the ground. So our height is 2 meters. And let's say it's got a range of, I don't know, let's go with 450 meters. Okay, ooh, that last one kind of got away from me. So our dx is going to be 450 meters. Okay, so we're firing it horizontally. So if I'm firing it horizontally, the main thing to remember about that is if you're horizontal, you only have a Vx. You don't have a Vy, or V naught y is 0. Now, let's say I ask you to find this initial velocity. We don't know what it is. Okay, well, to do that, I know what my distance is. Okay, so dx equals Vx times time. And in this case, I only have a Vx because V naught, in a sense, is Vx because I'm firing horizontally. So here I've got dx, I've got dx is 450, but I don't know Vx or V naught. I'm going to call it V naught because that's what we're looking for. And I don't know time. Well, this is 2 equations and 2 unknowns. You cannot solve an equation like that. So we're going to have to use a different equation to solve for time, and then use that to solve for V naught. And how do you get time? From height. Okay? Height is delta y. In this case, we're going down, so delta y is negative 2. So we've got delta y equals my V naught y times time plus 1/2 at squared. Now, we already said that V naught y is 0, so this whole term goes away. I'm left with negative 2 equals 1/2. Now my a is negative 9.8, and I'm looking for t squared. So negative 2, half of negative 9.8, you guys should be able to know that, or say that off the top of your head, is negative 4.9. And so negative 2 divided by negative 4.9, we're going to divide both sides here. Divide by negative 4.9, divide by negative 4.9. And so that comes out to be 0.408. 0.408 equals t squared. Now, we have to take the square root of both sides. So if you square root that, you get a time of 0.639 seconds equals my time. So now, I'm looking for V naught. Well, I just solved for time, so take that, whoop, plug it right back in. So 450 equals V naught times 0.639. So I'm going to divide both sides by 0.639. Divide by 0.639. So 450 divided by 0.639 gives me an answer of 704 for V naught. Now, it is crucial on your quiz tomorrow to pay attention to your units, okay? So this will be 704 meters per second. Now, I might give you a distance that may not be in meters, it might be in yards. you would have to convert it to meters because negative 9.8, or gravity, is negative 9.8 meters per second squared. Okay, so you have to keep your units consistent. So that's how you'd find an initial velocity. Or if I asked you to find the hang time, you could also use that. But this would be your answer if I asked you what is the initial velocity or the muzzle velocity of this projectile launcher. So let's keep going with this same projectile launcher. Its initial velocity is 704 meters per second. And let's say that now it's fired from the ground, but now it's fired at an angle of 15 degrees. 15 degrees. Okay, my V0 is going to stay the same. It'll be 704 meters per second. And let's say I want to know the total hang time for this projectile. Okay, so we don't know how far it's going to go. Okay, I want you to find out what is time. So we don't know dx. I don't know. And we don't know, oops, I just wrote dx. We don't know time. So we can use the fact it's fired from the ground and it ends up on the ground. So that means that my delta y is 0. Well, let's use the equation for delta y. Delta y equals my v0 y times time, and then plus 1/2 at squared. Now, v0 y. What is v0 y? How do you find the y component of this velocity vector? To find the y component, you always use sine. So in this case, it would be v0 sine of 15 degrees. And we know what v0 is. v0 is 704 sine of 15. So plug that into your calculator. I'm making sure that it is in degree mode. You don't want to pull a keister and take this whole quiz in radian mode. That would not be good. So our y velocity, it looks like it's going to be 182.2. So 182.2. And that is in meters per second. So now take what we got for v0 y, whoop, and plug it back in up here. And we know that delta y is 0. So 0 equals, there we go. 0 equals, my v0 y is 182.2 times time, which is what I'm looking for. And then 1/2 of a. You guys should be able to pick this up, that 1/2 a, you can just rewrite it as negative 4.9 t squared. As long as we are on Earth, a will be negative 9.8. So, negative 4.9 t squared, and I'm looking for t, so I can divide this whole side by t, canceling the t here, canceling one of the t's here. So I end up with 0 equals 182.2 minus 4.9 t. Now it becomes a simple one variable equation. So I'm going to subtract 182, subtract pin 182 from both sides. So I get negative 182.2 equals negative 4.9 t. Now I'm going to divide both sides by negative 4.9. And that is going to give me a total hang time of 37.19 seconds. And so that is my total hang time for this projectile being launched at 15 degrees. Okay? So now, what if I asked you to find this range? Okay? Well, now that we know time, this is a piece of cake. I know that dx equals vx times time. I just solved for time, and how do we find the x component of a velocity vector? The x component, you always use cosine. So it would be v0 cosine of 45 degrees. Okay? So plugging that in, dx is what I'm looking for. My v0, we figured out up here, it is 700 and, ooh, goodness. Let's just rewrite that. So we found out that is 704 cosine of 45 degrees. And then all of that times the time we just calculated, which was 37.19. So plug that in your calculator straight across. 704 cosine of 45 degrees, you want to be sure and close off the parentheses. When you're entering this in your calculator, you're going to have parentheses right here. You want to be sure and close that off, or otherwise it's going to do cosine of this times this. We don't want that. So cosine of 45, and then that times 37.19. And that gives us, whew, big number, a range of, it looks like it's 18,513 meters. So that would be how you'd find the range once you've found out the time at an angled launch. Okay? So now, let's look at another scenario. Let's keep our same launcher. That way we don't have to solve for V0 again. So let's scroll down just a wee bit. So let's consider our rifle is now, let's say it is 35 meters in the air. So that is my height. But let's say it's launched at an angle of 45 degrees on this hill. Okay? And so we don't know what my dx is. Okay? Because it's going to go up and then come down. And we don't know dx. We don't know time also. We don't know the hang time of this bullet. But we have figured out from the earlier problems that our initial velocity is 704. Whoops, 704. That is going to be everything we need to know to solve this problem. Okay, so let's first solve for time, the total hang time. Okay, to get time, we have to use height. Okay, so in this problem, delta y isn't going to be 0, it's going to be negative 35 because my bullet is going down. So the equation involving delta y is delta y equals v naught y times time plus 1/2 at squared. Now, v naught y, again, y component of a velocity vector, you are going to use sine. So it's v naught sine of 45. Well, plug in your value for v naught. It's 704 times sine of 45, and that gives you 497.8. So that is your velocity in the y direction, 497.8. That is a 9. It's a very sad looking 9. So now take that, plug it into your v naught y, and plug in also your delta y is negative 35. That equals 497.8 t, and then plus 1/2 a. That's minus 4.9 t squared. Well, now I can't divide both sides by t because I've got this negative 35 over here. I've got this height that I've got to deal with. So what you got to do is you got to add 35 to both sides. So you can't add it to this because this has a t. So this becomes 0 equals 35 plus 497.8 t minus 4.9 t squared. Boom, you got a quadratic equation. So this 35 becomes your c variable, the 497.8 becomes b, and then negative 4.9 becomes a. So t equals negative b plus or minus square root of b squared minus 4ac all over 2a. Sorry, I had to change the rhythm there because my pen has trouble keeping up with the tempo that I like to sing that song. So t equals this. Plug in your values for b, a, and c, or you could come by my room, or you should have come by my room and gotten this program. A lot of you didn't. Those of you that have the program, if you still have your cable, you can share with your peers. But I am going to plug this in real quick to give you a value that we can work with. So b is 497.8, and then c is 35. So that gives us a total time. It gave me kind of a weird number, so give me just a second. It gave me time as a big old fraction, and it does that sometimes. Why? I don't know. 786, 153, all of that over 7733. So that being said, plug that number into your calculator. So 786,153 divided by 7733. And that gives you a time of 101.7 seconds. So, again, you don't have to have the program to solve this, but you do have to know how to solve a quadratic equation. What you have to do is figure out what's inside this radical first. Do the top part first, doing plus, and then divide by 2a, and then do the top part minus, and then divided by 2a. You can't do this divided by 2a plus this. You'll get the wrong answer. So you should get 101.7. So that's the total hang time of my bullet. Now, once we have time, we can figure out the range, because we know that dx equals vx times time. And we know how to solve for the x component of a velocity vector. We are going to use cosine. So cosine, we figured out v naught earlier at 704. So vx equals 704 cosine of 45 degrees. Plug that into your calculadora, and you get 497.8. What do you know? It's the same as our Vy. And why is that? Oh, impress me. Because it is a special triangle. 1, 1, square root 2. The angle right here has got to be 45. So the two legs of our triangle are the same. These two are the legs. But that's neither here nor there. So take this, plug it in for our Vx. I'm looking for my distance, or my range, dx. So this is your range, or how far the bullet goes. So that becomes 497.8, and then that times my total time, which is 101.7. So that times 101.7, that gives you, big old distance of, looks like it's 50,627. 50,627, and always write your units. Now, keeping this scenario, a nice maybe bonus question would be the max height attained by this projectile. Okay, so let's scroll down a little bit and let's talk about the max height. At the max height, we know that our y velocity is 0. Okay, so if our y velocity is 0 at the top, we can use delta y equals v naught yt plus 1/2 at squared. Now, this goes away. Now, this t is different. This is the time it takes to get to the max height. That can be a little tricky to solve. So let's look at the other kinematic equations we have at our disposal. We've got v final squared equals v initial squared plus 2a. In this case, it would be delta y. Ooh, this doesn't have time in it. And in this case, our v, excuse me, this isn't v naught y, this is vy. Our vy at the very top is 0. So our vy squared equals my v naught y squared plus 2a delta y. Now, our v naught y, we just found out up here, it's 497.8. This is going to go away. So 0 equals 497.8 squared. And then I'm going to go plus 2 times negative 9.8. And now delta y, we all know that delta y is y final minus y initial. My y final is what I'm looking for. That'll be the max height. My y initial in this case is 35. So I would write this as y final minus 35. Here we've got one variable and one equation. This is super easy to solve. So let's go ahead and square 498.7. And I'm going to go ahead and subtract that to the other side. So we've got, it's a big old number. It is, let's just go with 2.49, negative 2.49 times 10 to the 1, 2, 3, 4, 5. So negative 2.49 times 10 to the 5th equals 2 times negative 9.8 is going to give me negative 19.6, and then that times y final minus 35. Now, those of you that want to distribute this negative 19.6, you can. You don't have to, though. What you can do is just divide both sides by negative 19.6. So divide both sides by negative 19.6, and that gives you, I'm going to go ahead and shimmy back over here. That gives you on the left side 12,688. And again, if your numbers are different, it's probably because you're rounding different. As long as you are close to this number, that's fine. That equals y final minus 35. Last step, add 35 to both sides, and you get an answer, a final answer of 12,723 meters. And that is my y final, or the max height attained by this projectile. So that right there will be very beneficial. Each of these problems, each type of these scenarios, the equations that I used, all will be very, very, very beneficial for your quiz tomorrow. So make up a problem like the first one I gave. Instead of saying a height is 2 meters, say my height is 4 meters. Make up a new range. Say your range is 15 yards. You know, that could give you good practice on converting from yards to meters. Start here, make up a new first problem, and then keep going following these same steps and these same types of scenarios. It will be very beneficial for your quiz tomorrow. So, good luck tomorrow. I miss you guys, well, most of you, and I look forward to seeing you guys here pretty soon.